All right, I'm going to review dividing rational expressions. So before we get there, I'm going to talk about, well, let's talk about the most basic. So back when we did basic fractions, like say 1/2 divided by 3/5, whenever we want to divide two fractions, what we did is we took the divisor, whatever we're dividing by, and we flipped it or took the reciprocal and changed it to multiplication. So 3/5 is now 5/3, and it became multiplication. Well, what's nice about this is we just talked about and we've done multiplication before. So the only new thing about these types of problems is take the second fraction, the second rational expression, take the reciprocal, and now it's a multiplication problem. So if you know how to do multiplication problems, from there on out, pretty much a lot of it is exactly the same. There is going to be one more catch, and that comes in the restrictions. I'll talk about it when we get there. So we're going to divide the rational expressions and state any restrictions. So here's our original setup. Now again, the first thing I'm going to do is we want to flip the second fraction, and it changes everything to multiplication. So the first one, 32x to the third y, divided by y to the eighth, stays exactly the same. Now when you're rewriting, be super, super careful that you don't rush and mess up any rewriting. So we're going to flip the second fraction. This changes to multiplication. So now I'm going to have 8x to the fourth on top and y to the seventh on bottom. Now, before I get into the rest of this and doing the multiplication and simplifying, I do want to talk about restrictions. And this is where the tricky part comes in with dividing. So remember, the restrictions are we don't want 0 in the denominator. So in my original problem, I had a y divided y to the eighth and a denominator and 8x to the fourth. So using those, if I take y to the eighth is equal to 0, we're going to find y cannot be 0. That's one restriction. And then 8x to the fourth. Set that equal to 0 and solve. You would divide by 8, divide by 8. X to the fourth is equal to 0. So x cannot be 0. So notice how I have, and the denominators here are my restrictions, but here's the deal. After I flipped and took the reciprocal of my second fraction, notice how I have now a y to the seventh in the denominator. So in this case, it's not going to do a whole much, but you would take that y to the seventh, set it equal to 0 and solve and find again, hey, y still cannot be 0. You don't have to write it twice, but you see what's going on there. So what I did is I took restrictions from the original problem's denominators, because remember, we cannot divide by 0. I also examined and said, well, once I took the reciprocal here, this y to the seventh is in a denominator as well. So this entire piece cannot be 0, as well as this numerator. So my restrictions came from here, here, and here. Where on previous problems where we did multiplication, so I'll flip back to an old note video, previous problems we only got the restrictions from the bottom there. We never touched the numerator because it's multiplication, the numerator stayed a numerator. So the new thing is we get restrictions from all three of those pieces. Because this is a denominator, that's a denominator, that y to the seventh eventually becomes a denominator. So there are my two restrictions. So now it's become a multiplication problem. And you're going to find not a whole lot's going to change from the multiplication problems we did earlier. If you still struggle with multiplication, maybe watch the multiplying rational expressions 1 and 2 videos. So the top's going to multiply with top. So I'm going to go through and start with numbers, then x's, then y's. So I'm going to start with 32 times 8, which is 256. And x to the third and x to the fourth becomes x to the seventh. And then I have a y up there. In the denominator, I have a y to the eighth and y to the seventh, which that's going to become y to the 15th. So now I can get to simplifying this rational expression. So starting with numbers, 256, nothing else there, so we're still going to have a 256 up top. X to the seventh in the numerator, no other x is around. But we do have a y up top and a y to the 15th on bottom. So I have one y up top and I have 15 on bottom. If I take away one from here and take one from there, I'm now down to y to the 14th. So my answer to this first dividing rational expressions problem is 256x to the 7th divided by y to the 14th with restrictions y cannot be 0 and x cannot be 0. So I'm going to show you one more problem, a little bit more complex form. Two big rational expressions, one divided by the other. Now remember, whenever we're dividing rational expressions, we take the reciprocal of the second one. So we're going to have the original stays the same, x squared plus 9x plus 18, x squared plus 6x plus 8. The division changes to multiplication. And now I have x squared plus 2x minus 8 divided by x squared minus 3x minus 18. Now, before I can do any restrictions, I need to factor to be able to do some restrictions here. So, quickly factoring here, x squared plus 9x plus 18, that's going to be x plus 6, x plus 3. X squared plus 6x plus 8, two numbers that multiply to 8 and add to 6 are x plus 4, x plus 2. X squared plus 2x minus 8, two numbers that multiply to negative 8. It's kind of hard to see there. Two numbers that multiply to negative 8, but add to 2 is x plus 4, x minus 2. And then x squared minus 3x minus 18, two numbers that multiply to negative 18 but add to negative 3, x minus 6, and x plus 3. Now remember, restrictions. We never want our denominator equal to 0, so restrictions come from here, here, and since we flipped this, also here. So those pieces right there. So going through the restrictions, take each factor, set it equal to 0, and solve. So x plus 4 is equal to 0. I get x cannot be negative 4 there. Take that x plus 2 equal to 0 and solve. X cannot be negative 2. I'll go to the bottom here. X minus 6 is equal to 0. X cannot be 6. X plus 3 is equal to 0. X cannot be negative 3. So the numerator, x plus 4 is equal to 0. X cannot be negative 4. Now, it's the second time I had that. I only need to write it once, but you get the idea. Put this up here. X minus 2 is equal to 0. Solve that, and you get x cannot be 2. So this x minus 4 one's doubled up, but my restrictions are x cannot be 6, negative 3, negative 2, positive 2, or negative 4. So 5 restrictions there. So now that those are taken care of, remember with multiplication this becomes all one big fraction. So the entire top's all multiplied together, the entire bottom's all multiplied together. So it now becomes a simplifying problem. I have factors up top and factors on bottom. I just need to see common factors on top and bottom. So I see an x plus 3 for an x plus 3. An x plus 4 for an x plus 4. That's a plus 6 and a minus 6. Those are different. This is a plus 2 and a minus 2. Those are different. So what I have left in the numerator, the top, is an x plus 6 and an x minus 2. In the denominator, I'm going to have an x plus 2 and an x minus 6. So there is my solution with those restrictions. And that is dividing rational expressions.